Hi there. So in this section, we're going to be looking at a little further into our quadratic functions and some applications and their graphs, okay? So from a quadratic equation, we can always determine the direction that the parabola opens, its vertex, its axis of symmetry. Axis of symmetry is the vertical line passing through the vertex that cuts that parabola right in half. And then you can also locate x and y intercepts, all right? So I am going to start you with two basic graphs of a parabola. Get my pen going here. We can have parabolas that face up, and we can have parabolas that face down. And I'm just making it up, okay? So here's a parabola facing upward. Over here on the right, I got a parabola facing downward. All right? So a couple of things going on here. All right? So the vertex will always be the lowest or highest point on that parabola. So here, this would be known as my vertex. This vertex would be a minimum. Versus over here on the right, this vertex would be known as a maximum. Um, the a value, the leading coefficient, determines whether your parabola opens up or down. So a over here on the left, a would be positive. A is positive. Over here on the right, a is negative. Let's see, what else do I want to... Axis of symmetry. Axis of symmetry is the line that passes through the vertex, cuts this parabola in half. There you go. AOS, axis of symmetry. It is always an equation x equals, and then it's the x value of the vertex. Same thing over here on the right. There's my axis of symmetry. And it is still x equals, and it's the x value of the vertex. All right. There's a couple of ways that parabolas, quadratics can be expressed. The first is vertex form, and we haven't really talked about vertex form yet in this class, but ironically, a vertex form is actually the easier form in terms of being able to pick out the items that I was just referring to versus the typical form that we'll see on the next page called referred to as standard form. All right, so with our vertex form, this is, I'll highlight it here for us. So here's our vertex form. Y equals A parentheses X minus H squared plus K. That A is with the same A that I'm referring to up here, okay? So if that A, that number out in front is positive, your parabola opens up. If that number out in front is negative, your parabola opens down. The vertex itself is always h comma k, so you're able to just pluck off the vertex. You don't have to do any work whatsoever. But notice how that the vertex is h comma k. That means that you are taking the opposite sign of your h and then keeping the sign of k. The sign on A determines which way it opens. I've already talked about that. And your axis of symmetry then is going to be x equals h. And if you think about it, h is the x value of the vertex. All right, so I'm going to come down. I'm going to do example 1 with you, and then let you try example 2 on your own. Check yourself by the solution key. All right, so it wants us to find the vertex, which way it opens, axis of symmetry, and then we'll just draw a rough sketch. All right, so let me get my pen back. And so here I am finding, so let's first find our vertex. So our vertex, so remember, here's your A, there's your H, and there's your K. It's always the opposite of your H, so that'll be a positive 2 and then negative 4. So my vertex is 2, negative 4. Which way does it open? That depends on my A value. My A is a positive 3, so it opens, hopefully you agree, up. Axis of symmetry, always x equals, and then it's the x value of the vertex, so x equals 2. All right, so then I'm going to come over here, just crank out, like I said, a rough sketch. So I have a vertex at 2, negative 4. 1, 2, 3, 4. So there's my vertex at 2, negative 4. I know this parabola opens up. Again, we're going to be more precise here in a few moments, but we are, for now, just saying, okay, this parabola opens upward. And I will go ahead and put in the axis of symmetry. It's the line x equals 2, so it should pass through that vertex there. If you folded it over, it would be directly on top of itself there. All right. All right. Again, I'll let you try example 2 on your own. I'm going to flip it over. On the next page, we pick up standard form. And this, like I mentioned before, this is the form that you're most familiar with in terms of working with quadratics, that ax squared plus bx plus c. You have to have you have to have that a term. A can't equal 0 in order, because you have to have the x squared in order to be quadratic. So you have to have that. Now the vertex, when it's in this form, is a little bit there's a little bit more work to find, but it's not it's still very straightforward. This is the formula itself, negative b over 2a, and then f of negative b over 2a. I like, and in fact, instead of saying negative b over 2a, I like to read that as opposite b over 2a. That's in case if your b is already negative, sometimes folks can't figure out what to do with it. So if you say opposite b over 2a, then that just tells you, okay, whatever b is, make it the opposite. But I come over here to the right and I said, find x equals opposite b over 2a. Find that first, and then what you're going to do is you're going to plug that into your function to get what your y value is for your vertex. Still the same thing. The sign on your A determines whether which way you open. If A is positive, we open up. If A is negative, we open down. But we're working with that leading coefficient there. And axis of symmetry is still the x value of the vertex, or that opposite b over 2a. So I'm going to do example 3 with you and let you try example 4 on your own. All right, so in example 3, first thing I want to find is my vertex. So I'm going to identify here as my A, my B, and my C. So for my vertex, it will be in ordered pair. All right, so x equals opposite b over 2a. So that will be, here's my b. My b is negative 8, so opposite of that, so that's going to be a positive 8. Let me fix that. Positive 8 over 2 times my a, which is 2 times 2. So I've got 8 divided by 4, which is 2. All right, so the x value of my vertex then is 2. To find y, just go to your function. Everywhere you see an x, plug in 2. Plug in, that x value of your vertex. So the x value there was 2, so you plug in 2. If your x had been a negative 5 there, then everywhere I saw an x, I would have plugged in negative 5. So this will be 2 times 2 squared minus 8 times 2 minus 1. You should be able to type that in your calculator all at one time and land at negative 9. So there's my vertex, 2, negative 9. Which way does this parabola open? My A is positive 2, so hopefully you agree. It's going to open up. Axis of symmetry, x equals x value of the vertex. So x equals 2. I'll draw a rough sketch again. So I'm going to plot this vertex, so positive 2 and then negative 9. I'm just going to count by 3's over here. So 3, 6, 9. So 2, negative 9. And I'm opening up. And we can put that axis of symmetry in there as well. And there you have it. Rough sketch. Okay. Again, I'll let you try example 4 on your own. I'm going to flip it over. I am going to do example 5 with you and then let you try example 6 on your own, okay? All right, so here in example 5, it wants us to analyze this quadratic function. Some of this, actually all of this, yeah, because we just picked up the vertex, all of this now, with the exception of that first line there, everything else down here is a review, okay? Because these are all terminology and all things that we've already previously found in this class. So really only A, B, and C is the new material from this section. Everything else is review. All right, so in part A, it wants the vertex. So I'll come over here and let's identify, here's my A, my B, and my C. Vertex. So x equals opposite B, so negative 8 over 2 times A, so 2 times negative 1. Negative 8 divided by negative 2, so that gives me a positive 4. All right, so then to find my y, go to my function. Everywhere I see an x, I'm going to plug in 4. So I have negative 4 squared plus 8 times 4 minus 15. You should be able to type it in your calculator just like that and land at 1. So you've got a vertex then at 4, 1. Axis of symmetry then, x equals x value of that vertex, so x equals 4. Is this vertex a max or a min? And so you probably don't know that off the top of your head, but what you can do is just sort of think about, okay, this parabola is going to open up or down. It's got a vertex over here at 4, 1, so here's my vertex. I'm just going to do a rough sketch here. But because that leading term there is negative, this parabola is going to open down. So that vertex then is a maximum point, right? All right, so now part D, it wants you to find the zeros. So remember, zeros is where this function is equal to 0. So we find that by setting our function equal to 0. So I set negative x squared plus 8x minus 15 equal to 0. Let's go through and let's factor out a negative 1, because we always find that factoring is easier whenever your leading term is positive. So let's factor out a negative 1. That'll leave me then with x squared minus 8x plus 15 equals 0. Now we're ready to factor. The only way to multiply to give you x squared, x times x. Most common way to multiply to give you 15, 5 times 3. So outside and inside, I got a 3x on the outside, 5x on the inside. So 3x and 5x. My goal is to get that middle term, which is negative 8x. I can get that. I'd have to make them both negative. And then that checks out the end. Negative 5 times negative 3 gives me a positive 15. I set every factor then that has a letter with it equal to 0. So I don't need to start worrying about negative 1, but I would set x minus 5 equal to 0 and x minus 3 equal to 0. Solve for x in both cases. So we get a positive 5 and a positive 3. So our zeros then are at 3 and 5. Now remember, the only difference between zeros and x-intercepts is the way you report it. So I don't have to do any work here. I just need to change these into x-intercepts, and so make them order pairs. All right. So now to find my y-intercept, excuse me, to find my y-intercept, remember for your y-intercept you let x equal 0 and you solve for y. So these are pretty straightforward. Everywhere you see an x, plug in 0. And so that cleans up nicely. Should be able to eyeball it then. Got negative 15. Excuse me. All right, so now we're ready to graph. And we're going to get a little bit, a much more precise graph. All right, so I'm going to plot the vertex, 1, 2, 3, 4. And let's see, I'm going to have to get a negative 15. So let me count by 3s on this y-axis. So I'll count by 1s on the x. And it's legal for, I mean, the two axes can have different scales just as long as you're consistent on each scale. So I can count by 1s here. 1, 2, 3, 4, 5. But let me count by 3s on the y-axis since I need to get down to 15. So let's see, 3, 6, 9, 12, 15. Oh, really cut it close there. All right, so I'll do the same thing over here. 3, 6, 9. So just counting by 3s. All right, so this is negative 3, and this down here is negative 15. All right, so I'm plotting my vertex 4, 1, so that's going to be just barely above the x-axis there because of the way I've scaled it. Okay, I have x-intercepts at 3 and 5, and I've got a y-intercept down here at negative 15. Okay, so kind of get you a rough sketch there then. Looks like that. So, and then, you know, you've got that axis of symmetry there of x equals 4 that would cut it right in half if you wanted to plot that in as well, but we're fine here. All right. So now the next piece is asking you the intervals for increasing and decreasing. So remember, for the intervals for increasing and decreasing, you go and start tracing this graph. And so if I trace it from left to right, on the left-hand side, I'm increasing up until I get to that vertex. So I'm increasing from negative infinity to 4. And then I decrease. Remember, for increasing and decreasing, you're always reading the x-axis. So then from 4 all the way to the right to positive infinity, just think about your x's. X's on this side are positive. So 4 to positive infinity, I am decreasing. Domain. Domain. Sorry about that. All right. Sorry about the interruption. All right, for your domain, remember you're looking at your graph here from left to right, and so this graph is going down into the left forever and down into the right forever, so it's going left and right forever. You can also go back and look at the function itself and ask yourself those same domain questions. Is there a letter in the denominator? No. Is there an even root? No. Your answer no to both of those questions. Domain, negative infinity, positive infinity. All right, range is the only time we read our y-axis. So as I read my y-axis here, this graph comes from the bottom. All right, so it's coming in from what kind of infinity? Negative infinity, up until this highest point here, and the y value there is the y value of that vertex, be 1. So negative infinity to 1. We'll put a bracket on that 1 because I can't equal. Domain and range can have brackets. Increasing and decreasing cannot. Okay. All right, I encourage you to definitely pause the video, try example 6 and on your own, and check yourself by the solution key. I'm going to flip it over to the last page, and let's work through a couple of these application problems. So here in example 7, it says the height of a ball is thrown directly upward from a point 200 feet above the ground with an initial velocity of 40 feet per second is given by this function here. Here's my height function. T represents time that has elapsed since the ball was thrown. Time is being measured in seconds, and height is being measured in feet. So just to sort of give you a kind of rough sketch of what's going on, so you can think about it, the ball was initially thrown from a height of 200 feet. It's going to reach a maximum height, and then we know what goes up must come down. Okay, so that's kind of, think about that then as the trajectory of the ball, and that this is where it started at that 200 feet. So this is our height over here, measured in feet. And we got time down here on the x-axis, measured in seconds. Okay. In part A, nothing fancy here. Determine the height of the ball after 3 seconds. So looking at my equation here, I just want to find h of 3. So everywhere I see a t, I'm going to plug in 3. You should be able to type that in your calculator all at one time and land at 176 feet. Final answer. So after 3 seconds, we're at 176 feet. In a few moments, I'll come over here and put that on the graph, but I don't want to do it too soon. All right, in part B, it wants to know when did the ball hit the ground. So I'm trying to figure out what's this time right here. I have hit the ground. When did that happen? All right, so that would be then, if you've hit the ground, what is your height? I agree, your height would be equal to 0. So when I hit the ground, that means that our height is equal to 0. So I'm going to take my function there, negative 16t squared plus 40t plus 200, and set it equal to 0. All right, so let's help ourselves out here in terms of factoring. All 3 of these terms have a number in common. You could do a little bit of trial and error here, but they would all have an 8 in common. And let's go ahead and factor out a negative 8 so that my leading term will be positive. So I'm going to factor out a negative 8, write what I have left over. All right. Now from here, we're going to factor. The only way to multiply to give you 2t squared, 2t times t. Most common way to multiply to give you 25, 5 times 5. All right, so remember we check our outside and inside. So on the outside, 2 times 5, that's giving me 10t. Inside, it's giving me 5t. My goal is a negative 5t, so the only way that I'm going to get a negative 5 out of those two would be that I have to make my 10 negative. I'm getting 10 when I do 2 times 5, so the minus sign goes in front of where you get it. So now I set any factor that has a letter with it equal to 0, so I don't need to worry about the negative 8, but I'm going to set 2t plus 5 equal to 0 and t minus 5 equal to 0. Solve for t in both cases, so 2t equals negative 5, divide by 2, so t equals negative 5 over 2. We're talking about time, so negative 5 divided by 2 is negative 2.5, so that negative time doesn't make any sense, so we're going to ignore that one. Come over here, solve for t, so I pull that 5 over, so t equals 5 seconds. So then we know now that that time there is 5 seconds, and then so roughly then about that 176, we'd say probably is roughly about here. So this would be my 3-second mark. So my graph over here is definitely not to scale, but we knew that at 3 seconds it was at 176 feet. Okay. Part C wants to know, when does the ball reach its maximum height, and what is that maximum height? So now I'm trying to establish this point right here on my graph. So when does it reach its maximum height, and what is the maximum height? Anytime you're asked to find a maximum or a minimum, you're referring to the vertex. So we want that vertex formula that we had earlier in this set of notes. So x equals that opposite b over 2a, so opposite of your b over 2 times a. So that gives me negative 40 divided by negative 32. Reduce that, or just you just pop that in your calculator. That should put you at 1.25 seconds. So we're saying then this is at 1.25 seconds. I reach that maximum height, and then to figure out the maximum height, just go to your height function, and everywhere you see a t, you're going to plug in that 1.25. And that should land you, be able to put that in your calculator all at one time. That should put you at 225 feet. So that's the maximum height. This is when it happens. So we're saying then at this height right here, that's 225. Okay. Anything else on that one? Nope. All right. Example 8 is very similar to that one, so I will let you try example 8 on your own and check yourself by the solution key. I think, let's see, hitting the water, maximum height. Yep, exactly. All right, so let's do example 9 together. In example 9, it says the profit for selling X boxes of candy is found using this function here. In part A, it wants to know how many boxes must be sold to maximize the profit, and what is the maximum profit. So again, anytime you see that word maximize or minimize, you're referring to the vertex. So in part A, it wants to know how many boxes. X are your number of boxes, so X equals your opposite B over 2A, so negative 8.25 over 2 times my negative 0.04. Do that division, and that should land you at 103.125 boxes. And then to find out the maximum profit, you're going to go to your profit function, and everywhere you see an X, you're going to plug in that 103.125. You should be able to put that in your calculator all at one time. Profit then, $175.39. All right, that finishes this section. Thanks a lot. Bye.